Hello all, my name is Shan Singh and welcome to my YouTube channel. So this is the fifth tutorial of this statistics playlist where we will try to understand what the probability actually is. See, probability actually is a fundamental area when it comes to machine learning and deep learning algorithms. So let's try to understand probability in a simplest possible way using some day-to-day example. Let's understand that. So yeah, hi all. Let's understand what the probability is using day-to-day example and using a real-world example. So very first, let's learn in context of a day-to-day example. So imagine I have a couple of simple statements like sun rises in the morning. So all it means is that it has a probability of 1, or you can say there is a 100% chance, right, that sun rises in the morning. Similarly, let's say weather forecast has forecasted that there's a 50% rain chance today. It means we have a probability of 0.5, or we can say that there is a 50% chance that today it will rain. Imagine one of the student has obtained 104 marks out of 100. So you will say that it has a probability of 1 because it is actually an impossible task, right? So see, in general, probability value basically lie between a range of 0 to 1 in general. So if something is certain, or if something has a 100% guarantee, we can say that for this I have a 100% probability, or I can say we have a probability of 1, right? When we have a probability score of 0, all it means is that the task is impossible, right? It means it has a 0% chance, right? Let's say for some case we have a 50-50 case, 50-50 probability. I can say for this you have a 0.5 probability, right? See, you can basically compute probability using a very simple formula, which is all about number of time event happens gets divided by the total outcomes we have, right? It's a very simple thing. Total number of outcomes we have. So let's consider a very simple example. So imagine I have to order a pizza, right? A pizza from a cafe or a restaurant, right? And let's say this pizza has 4 toppings. So it could have a cheese topping, it could have a veggies topping, it could have a paneer topping, right? And let's say it could have some corn topping. But if I will ask you, can you tell me what is a probability that I will end up getting a corn topping on pizza? Can you compute that? So just to compute it, I will say it is all about a 1/4, because only once corn is available among all the 4 topping, and 4 is the total number of the outcome. Hence I can say that we have a probability value of 0.25, or we have a 25% chance that we will have a corn topping on pizza, right? It's a very simple idea. Now let's try to connect the idea using a real world example. Let's consider a airline data. So imagine in this data I have couple of interested features. What is the source of a flight? What is the destination city, right? What is the date of journey? What is the route defined for that flight? The duration taken by flight, and there is a very interesting feature whether flight got delayed or not. Let's say I have a flight of Delhi to Mumbai, and let's say it is scheduled on 21st of July, and it have some XYZ route defined. The total time taken is 2 hours and the delay is 10 minutes. Similarly, for some other route, let's say between Lucknow to Calcutta, right, the date of journey is right, and then we have a delay of 15 minutes. And then let's say we have couple of interesting entries, right, and let's say these are total 10,000 data points, right? These are total 10,000 data points. And let's say for a new point, let me term it as a XQ, or oftentimes it is termed as a query point. And for this I have to predict whether the flight will delay or not. So let's say among 10,000 data points, okay, so we have a total flights as 10,000, right? and let's say among 10,000 the delayed flights, their count is actually, let's say, 300. So if I will compute the probability that the flight is going to delay, or the flight being delayed, it will be all about the number of times a flight delay, right, which is exactly 300, and the total flights are actually 10,000, right? You will see here is a value we have. So if I will do a simple division, it is a 0.03, which is, you can say, a 3% chance that a flight is going to delay, right? Okay, so for see, instead of telling that whether the flight will delay or not, right, what it is telling, it is telling us actually a probabilistic score, right? Let's say with respect to delay we have a score of 0.03, with respect to not delay we have a score of 0.97, right? So instead of telling directly whether it will delay or not, it is actually telling us that probabilistic or a chance based score, right, or a chance based score, and that's how exactly probability is used in machine learning. So that's all about this session. If you guys have any doubt, please share with us in the comment section. That's all about it. Take care and God bless you.